All right. Thank you again for joining us today. Good afternoon, everyone, especially if you're based in India. And we are also expecting a good turn up today. It's Saturday. And yesterday, where we left off was we discussed almost 40–50% of the basics of blockchain technology, the basic concepts. And pretty much we haven't yet covered how consensus works in a distributed network. That is one very important topic for today. And apart from that, we have, as usual, I'll start with some numbers, some facts and figures, apart from what we saw yesterday. But there were pretty important numbers that we definitely saw yesterday, which I'll iterate once. And apart from that, today we will try to get some hands-on done here. Today's hands-on won't need you to do hands-on concurrently. It would be, you can see in my screen, and it would be pretty easy, but it should be very interesting because we will take a look at how we can actually see how public the public blockchains actually are, and we as general public sitting on a webinar, how much information can we get from these public blockchains. When you will compare this with any centralized system or any centralized database management system, for example, MySQL or Oracle, or a NoSQL database such as MongoDB. Just compare any of these with what we will see today, and you will understand that there's a humongous difference. And the control is the control lies in the hands of the public mostly. Not write control, of course, only read control, because write control, there's nothing like write control in a blockchain after a block has been put into the blockchain. So this is what we had covered yesterday. I will just revise a bit for people who have joined us new today. Yesterday we discussed that the basic characteristics of blockchain are, first of all, it's an immutable ledger. It's basically a ledger. You record transactions on a blockchain. Anything. It does not have to be a financial transaction. It does not have to be that you are sending maybe 10 bitcoins. You must have heard 10 bitcoins to someone, a friend of yours. It does not have to be that. Anything that you do on a blockchain network is considered a transaction. In addition to that, so for example, even so for example, a very good example is that this entire FDP, when after this FDP, we will be issuing certificates on the public Ethereum blockchain, the same Ethereum blockchain publicly, which we will be seeing today. What you will see that, so that has been issued, and that's a certificate. That's not a financial transaction. We are not giving you any kind of money in dollars or in ethers, but still that will be considered a transaction on the Ethereum network. So transaction does not need to mean it involves money, but anything that happens on a blockchain network is termed as a transaction. In addition to that, we discussed yesterday that apart from being, so the first, everything is a transaction on blockchain, and the first characteristic is very important. Is that a blockchain network is immutable. Once a transaction goes into a blockchain, I mean, it goes into a block, and then the block is made, and that block is put into a mine and put into the network, the blockchain network. You cannot change it. You cannot change anything in that entire block. There could be 10 different transactions, there could be 100,000 different transactions, or there could be one transaction. You cannot go back in time and change anything in a blockchain network. If you compare this with technology like RDBMS or MongoDB, you must have seen that you can definitely go to your PHP MyAdmin and just change your MySQL records, or you can just log on into your MongoDB servers and then easily commit any kind of changes, any kind of create, read, update, delete operations on the database without anyone's approval. You just need to have the key, the password, and the username to the server. That's it. With blockchain, this situation, this entire use case completely changes. Once anything goes on the blockchain, please remember, you cannot change it ever, right? So this is what we had discussed yesterday about blockchain. Another characteristic was transparency. However, also another characteristic that goes very well in hand with this particular characteristic, and which creates a lot of confusion in a lot of my students, as I've seen, is of the characteristic of anonymity. People get confused that if you're saying it's transparent, it's the most transparent technology available there in the market, then how can it be anonymous? I mean, these two are these two could be synonyms, right? So what happens is that a blockchain is typically transparent. So there are different types of blockchains. I have not, we don't have it today in the slides because we were supposed to cover it yesterday, but I'll give you a brief overview. We have very different blockchains. So we start with a public blockchain. That's the most common type. Going forward, we also saw blockchains coming in the market, which were either private blockchains, but more or less private blockchains don't mean a lot because if a blockchain is private, then more or less it's again under the control of a centralized authority. But it does not mean that these kinds of blockchains do not exist, because a lot of places, a lot of banks, a lot of areas, you will see the use of private blockchains. They might not be decentralized in its truest sense, but what happens is that these organizations utilize these kinds of blockchains to make sure that the data is private to them. The data is not out in the open and not shared with any other stakeholder. Also, they make sure that, however, even they are able to protect their data, but also they are using the blockchain technology, even though it's a private form of a blockchain implementation, but they're using blockchain technology just to gain use of or to use the basic characteristics of the blockchain technology, which is again immutability, transparency, anonymity, all of these, and that source of truth. So whenever something happens, for example, if it's a bank and then an auditing happens, even though it is a private blockchain, but that blockchain will definitely be valid to be audited, because the basic characteristics of blockchains don't change, even if it's inside a centralized authority. So everything starting from the first Genesis block, the first block in a blockchain is called the Genesis block. I will see to it today or tomorrow, a very simple concept. And right from the Genesis block up to the current block height, again, another term you'll see everywhere is that block height. Block height of a blockchain is the last block that was mined as of now when you're checking. So that's what a block height is. And so everything in between, even for that bank who is using a private blockchain, will be there. It will be there. The source of truth will be there, because the technology, underlying technology of writing the transactions into a blockchain is going to be same, right? With that in mind, so these are, and there's another type of blockchain called permissioned or consortium blockchains. We'll take a look at it later. So these are the various types of blockchains, but essentially in the case of a public blockchain, the third characteristic that we were talking about was anonymity, while also having transparency. What happens, we saw that yesterday, but I'll take a couple of minutes to revise in case a lot of a big segment is new today. You are joining us for the first time maybe. So what happens is that when we are looking at a public blockchain, you will see every bit of information about that particular transaction happening that has happened in that particular block. However, there will be no linkage with who owns that particular transaction. So there would be two different parties between which the transaction would have happened, but clearly you will only have the address for both of them. That address is a hash, and which is easily 30, 36, 40 characters long. So you cannot really make out any information from that one piece of string. That is what you will be seeing, that this particular piece of string, this transaction hash transferred 10 bitcoins to this transaction hash. This transaction happened on 20th of May at 4 p.m. IST. 10 bitcoins were transferred. 0.5 bitcoin was the transaction fee that goes to the miners, and it has till now it has done 2900 confirmations. We'll see what confirmations means later, and you'll get all of this information. However, what you will not get is who exactly did that transaction. That is pretty much anonymous, right? I send you 100 rupees via Paytm. It is very easy in these days to make out which to whom both the numbers between which the transaction happened belongs to, right? Same thing is not possible because we do not have a true caller for blockchain yet, and that is completely against the basic characteristics of blockchain, because then it won't be anonymous. If you can just put down a hash and it gives you who this hash belongs to, the essence is killed, right? And in addition to that, you will not have any other information about the actual entities who are dealing in that transaction. So that is how it is public. It is transparent. However, it is as well as Divya ma'am, Pushpa ma'am is calling me. So can you see, is there a problem with my audio or something? Maybe. Divya ma'am, can you just check if I'm audible and all perfectly clear, because I'm receiving the call? I'll open the chat once as well. I didn't want to do that. screen is blur, little slow today as well. Okay. Yeah, we are not moving PPT because, okay. All right, so one query came that we are not moving PPT because if I move the PPT, then sadly the new segment of people who have joined us today, they will not be able to understand that what I am talking about, because I am just taking 5-7 minutes to revise to revise exactly what we learned yesterday. And I'm trying to go slow on that because there are a lot of new people expectedly who have joined us today itself. So I'm just revising that because after I cross the welcome slide, it will be all today's matter and today's content. So just bear with me a couple of minutes. I'm done with the revision. I hope that was sufficient. All right, I'm closing the chat again. I'll continue. I'm almost done with the revision from yesterday. So yeah, so that is where we were, the basic characteristics of blockchain: transparency, anonymity, immutability, security. All of these things are the core characteristics of blockchain. This is what we had discussed yesterday. If you're joining us here today for the first time, and moving on, we'll take a look at further concepts, but they are not very interlinked. So don't worry if you are joining us for the first time today. And anywhere any concept comes that has been dealt with yesterday, I will make sure I'll give a line or two about it today as well. Right. With that, I proceed. So welcome to the faculty development program on blockchain technology, day 2. Of course, we'll for the people who are joining me today for the first time, just a brief introduction of what I do in my general commercial life. I'm a co-founder of the Startup World, also a blockchain-based startup. We are, and I am Ahmedabad incubated startup, and also the India Stock Management School. Ahmedabad is making a case study on us. We have got a sufficient amount of traction even in these lockdown days. We went from 5 warehouses in Maharashtra to a pilot of 1,000 warehouses in the state of Maharashtra. And apart from that, I've been into blockchains in the last 3.5 years, and pretty much academically as well as commercially. With that, I'll just proceed and take on the day's content. All right, today's bird's eye view. We will first of all take a look at the remaining basics going ahead, because there were some really important pieces of basics which were pending since yesterday, and we could not cover them yesterday but they are important, so we will cover them first. We will about 30 to 40% of basics are remaining today, which includes consensus mechanisms as the most important topic. But again, it's a pretty basic topic, but a very important topic. And apart from that, we will take a look at so apart from that, we will take a look at hands-on experience, which we just discussed. We'll take a look at Merkle trees, Merkle hash. We'll take a look at distributed consensus and how do systems arrive at a distributed consensus. I mean, arrive at a consensus in a very distributed system. A lot of factors come into play. And going forward, we'll take today I found a very good video from BBC News, which explains that how the system exactly works. Not from the technical standpoint. It's a it's an animated kind of a video mostly, and the video actually tells you pretty well that the video tells you that how the system works in terms of payments and using blockchain technology, and how the centralized system differs from the decentralized system. And this is what I had explained for about half an hour yesterday. Had I got this video, it would have been done in 3 hours, 3 minutes actually. So, but we will see this video today. It will give you a very clear idea of what centralization is and what decentralization is, right? It does show Bitcoin there, but we are not talking about Bitcoin here. We are talking about blockchain in general, right? That's it. That should be it. We will take a look at a couple of anecdotes that happened in the Bitcoin and Ethereum networks. We'll do a couple of polls in between. As you can see, polls to gauge understanding of what you are studying here and how it's going, or whether something needs to be changed, right? Basic hands-on is there, where we'll be seeing and exploring the Ethereum blockchain publicly. And apart from that, we'll take a look at generations of blockchain, and we'll understand that where we came from in the last 11 years, starting since 2009, when Satoshi Nakamoto brought out that the first implementation of blockchain technology, which was a cryptocurrency called Bitcoin. Everyone by now knows that already, I know. And since the last 11 years, blockchain has come from the first transaction that happened in blockchain. We'll take a look at that. We have a day named after that particular transaction. It was a very it's a funny transaction if compared today. And we'll take a look at that. And then we'll see that how it has come from there to hear when when World Bank is calling blockchain as a pillar for the fourth industrial revolution, comparing it with breakthrough inventions and technologies such as the internet and the steam engine, and studying that, what it means to study that, and what it means to get into this technology commercially, academically, or any way possible, right? And at the end, we'll see that what's the preparation for the last day, that is tomorrow. We might stretch a bit tomorrow because believe me, I had 4 or 5 days of content. Yesterday, I could just cover 20-25% of that. So there's a lot of content to cover. So we'll most probably extend tomorrow's session, considering tomorrow is a Sunday. It's holiday, and so we'll take a look at that. That's it. Let's begin. All right. So yesterday we started with this question. We finished off actually with a series of topics which were under this question. So is the answer to all of the problems that come out from centralized technologies, is the answer a distributed ledger technology? Is it DLT? How we are going to answer those problems? Is it blockchain? Blockchain is a type of DLT, and why? Typically, why is blockchain an answer to all of those problems that we have seen? We have been seeing, even many have not even realized that those are actually grave problems, grave issues, because your money is being handled very well by the RBI, by any of the banks, right? And then every day morning you're fine with giving control of all your data to a centralized entity like, say, Google, right? I'm not saying that these organizations will any day go rogue. What if another implementation could be in a supply chain management? What if such organizations who are dealt with who are very closely related to some implementations, like the food chain, like take an example of a food chain implementation. What if the entities in a food chain network, they happen to record incorrect data? You will never get to know what quality of food items you are consuming. On the other hand, if you are abolishing that, if you are trying to use a technology which removes all of these complexities, which removes all of these demerits of the centralized system, and then in return gives you a source of truth which you can check publicly and then know exactly the food you're having today, where it was grown, where it was sown, where it was harvested, where it was kept, the warehouses it was kept in, and where it was manufactured, how the delivery happened, and now you're having that food. So this is sheer power. This is very powerful, making you very powerful as a consumer, to per se. It has just showed me that my internet connection is a bit stable, is a bit unstable. So please, if you, Divya ma'am, if I break, please just let me know. And if I'm not able to hear you, then please just give me a call, short call. I'll understand that something is wrong. Right. So let's begin. Again, as I said, that today we'll be taking a look at 1 minute of facts and figures. That's it. Yesterday I started with very important facts and figures. Today we'll look at a couple of facts from the country. If you're from outside, you will be able to relate it, because believe me, if I am talking about numbers from India, they are pretty much the same across the world. It is not that any other country like US or any country in Africa, they are way ahead. It's not that. In terms of blockchain, when we are talking about the blockchain industry, pretty much everyone is fighting, pretty much everyone is struggling to come out ahead, be it any organization or be it a country, right? Some countries are definitely ahead of what India is doing, and we'll take a, maybe we'll discuss some of those in the flow. We don't have a slide on that, but that's where we are, right? But yeah, these numbers you can pretty much relate to. So technically, in India, excuse me, with an early lockdown and encouraging digitization a lot, the Indian government was able to somewhat put a control on the economic slowdown. We saw comparatively less number of jobs lost, but now clearly that is growing heavily. A lot of my acquaintances have lost jobs. I see every day on LinkedIn that some of the other company are doing a lot of layoffs. Some days back, Zomato, the HR of Zomato had put out a LinkedIn post saying that we had to let a lot of people, 13% of their workforce. 13% of Zomato's workforce is a humongous number, and they had to let go of them. And they were asking that if anyone has a need, then they may please take them, right? They may consider looking into them. Some days back, IIM Ahmedabad had a few students from IIM Ahmedabad who were supposed to intern at very good organizations this summer, which crossed by now. They were planning to intern there. They had good offers from those organizations, but right after the lockdown started, their offers were revoked. And so just imagine a top management school in a country like India, where the competition is so high that only the cream of the cream reach a college like IIM Ahmedabad. Still, even students from there are losing their internships at such a time. So we can easily understand that what is going to happen with everyone else across the country, right? The kind of job losses, the kind of opportunity losses, the kind of economic slowdown that the entire country will face eventually, right, because of this pandemic. So that's where we are. Just to take a look at the numbers. Currently, 10 crore jobs are at stake in India, and that is pretty much going to increase. If you're just following the everyday numbers, you'll see that this 10 crore is still not a number it's not a conservative number. This is going to be very high, especially if you're talking about in IT, because we are in the field of IT. News articles say that 1.5 lakh jobs in IT will be at stake. But believe me, looking at 2008 eight recessions data, 6 lakh jobs in IT were lost. So if a global recession like 2008 made 6 lakh jobs in IT go off, it is clearly evident that this 1.5 lakh is a very small number. This will go way beyond that. This can go easily to 8 to 10 lakhs. We just have 20 lakh engineers, IT engineers in the country. So if it becomes 6 to 8 lakhs or 10 lakhs, that's 40-50% of our IT workforce. This is concerning. A lot of mass recruiting companies are planning to lay off. They already either have laid off a lot of employees, or they are planning to do so. It is a very concerning situation. And if you are not able to get ahead, you are going to fall into this. And but on the other hand, so these are definitely concerning numbers for the country. On the other hand, if you want to stay ahead of the curve, it has become very, very, very easy. Mark my words, it has become very easy to do so right now. First of all, you got 2.5, 3 months of lockdown just happened now, right? That was a big time. If you've not utilized that, you've missed out on that. But still, going ahead, even the economy would anyways be slow. So you'll get a lot of time, believe me, to invest in yourself. Even if you don't, you should take out time, because otherwise you will be one of those 1.5 lakh people. Clear cut, right? You have to be very concerned about your future as well. So I believe even before learning any of the basic concepts of blockchain, I believe this is an important number for every one of you if you're planning to build a career in blockchain, because blockchain is a technology which is growing at a very fast speed, and there's not a lot of competition into this field, especially in a country like India, where the competition is so high in every sector that we can take a look at. In blockchain, yesterday, right, just as of yesterday, I had shown some very good numbers where out of the entire IT industry in the country, which is an estimated 20 lakh IT engineers, 2 million IT engineers, 0.25% of them is that's all who had any kind of blockchain skills. Now, this is concerning for the country, but this is very, very, very beneficial, a very good number if you take a look at, and if you plan to build a career in blockchain. Because just imagine, what will it take to come ahead of those 0.25% engineers, or let alone the remaining percentage of the engineers who have nothing to do with blockchain, right? Who don't know about blockchain. There's hardly any competition. I had said this thing yesterday, mark my words, if you, starting today, learn blockchain for the next 1 week, and believe me, consider these 3 days of the FDP into it, spend 4 more days after this, and that's it. 1 week is all that's going to take for you to get a good start in blockchain. And from there, you can unleash yourself. You can learn the technology, you can learn designing blockchain applications, product management in blockchain applications, security in blockchain applications, or actually become a blockchain engineer by learning all of that stuff that either we'll cover or is already available in the internet. 1 week to transform your career, believe me. With that, we'll go ahead. Remember, we are studying 2020's #1 skill right now. That is why it's more important. It's not only a pillar of the 4th industrial revolution, it is 2020's #1 skill as called out by LinkedIn. Very popular skills of artificial intelligence and cloud computing are at #2 and #4. Right? With that, I hope you're equally motivated to learn this beautiful technology. Believe me, this is a very different kind of technology, which is something that you have not really taken a look at in your maybe in any time in the past. The basic concepts are a bit different. They are basic, but they are different. It does not work the way every other, centralized systems you've seen to work. But with that in mind, this is one of the best technologies I've seen in my life till now, apart from quantum computing and all those which are yet to come, right? So let's get ahead. This is where we left yesterday. This is exactly the point which we discussed and we left yesterday. So this is from where we will begin today. I hope if you're joining today, you will join tomorrow as well, so that you have that continuity. However, things are not very linked, so you may please continue. You'll understand most of it. All right, so the behind the scene, we had discussed this slide in detail, so I'll just cover it in a couple of minutes and that I'll be done. What happens when behind the scenes, the mathematics that's played behind the scenes when we are talking about blockchain, right? Okay, so to start that, before we start that, I wanted to understand that what is the kind of audience that we are having today. So guys, with that in mind, can you please take a look at a poll that I'm starting? It is going to take you exactly 10 seconds to answer this poll, and we'll get the results right away. So that this is why this is important, because even though the slides have already been made, but based on the answers here, I can modulate my presentation accordingly. Because if 90% of you are entrepreneurs, the presentation will completely be different. If you are faculties, if you're PhDs, if you are students, if you're researchers, it will be completely different, right? So please, I'm launching a poll. I would request all of you to please, if you see the poll on your system, please start answering. I see people have started answering. Thank you very much. No entrepreneurs yet. No entrepreneurs yet. Please, some entrepreneur attending this workshop, please come up. Yes, thank you. 3 entrepreneurs yet. Oh, that's a lot of faculties. Yes, of course, it's a faculty development program. Out of the 800 odd registrations we've received, 90% are actually faculties from across the world. That includes the US, France, Germany, Australia, Malaysia, and of course Pakistan, Afghanistan, and all other countries apart from India. And that has been heartening, really. 94 of you have voted, 100 more to go. We'll give 1 minute to this. Also, in some time, I'll be sharing a feedback link. People who have filled that feedback yesterday, I want to thank them from the core of my heart, because they were wonderful feedback. Some were very critical feedback, and those have helped me a lot. And I really believe that some of those, some changes based on yesterday's feedback, you might be able to see today, because this is one thing that I am trying to do. If you're giving any feedback, I'm trying to incorporate it then and there. So 105 have answered. That's 53% of our current strength. Why are others not voting? Please vote, because otherwise I'll understand that either you are not an active part of the lecture. I'll be very disheartened by that, to be very honest, because a lot goes into preparing a 3 days worth of blockchain content. That covers entirely a lot of ground. We'll give it 30 seconds more, because this is important. By the time I reach 70%, I'll close this, because that's fine. That's enough. I see there's a clear leader already. Please, guys, if you're listening, if you're there near the computer, on the mic, please vote. Please give me your response of which profession you belong to, because that's important. All right, I've received 62%. There's a clear winner. 80 of you are faculty till now. That's more than 60, 65, 70%. And rest are student. A very small percentage is our entrepreneurs. Please count me in with you. So that makes 7 of us who are entrepreneurs, and some people belong to some other sectors. And okay, someone is saying that poll is not appearing. It appeared for a few seconds. So all right, if there's a technical problem, but I have received a lot of responses, so let's go ahead with that. Thank you, Seema ma'am, for that feedback. Thanks a lot. I'll just close the poll now. All right, great. Sharing results with you all just for you to see. Take a look, and that's where we proceed. So accordingly, I will be modulating it, the presentation. It will be completely different as to what I was planning. Not really. We were planning for a faculty development program, but the agenda, the way of presenting would be significantly different. I'm closing the poll now. Done. All right. coming back to the slides. So this is where we left yesterday. We'll quickly take a look at where we ended. What happens behind the scenes when we are talking about blockchain as a technology and you're putting out transactions that are getting into the blockchain network? First of all, a blockchain, a block of transactions that goes into a blockchain network is cryptographically hardened. What does that mean? What is it, cryptographically hardened? So as I see, 80% of you are faculties, rest are students. You have already been teaching cryptography for maybe the number of years that are that okay. Okay, all right. Divya, have you started the poll again? All right, even if you're seeing the poll again, that's taking a small part of your screen. Let's move ahead. If you've already given, the poll must have already gone away. All right, so that's great. And so that's where we are. Cryptographically hardened means that everything happening in blockchain, cryptography plays a very, very, very important role in everything that's happening in blockchain. That is why in my own book, the first entire part of the book is on cryptography only. You can understand in a blockchain book, if half of it is covering cryptography, how much importance cryptography has in what role it has in blockchain, right? So everything happens cryptographically. When we are talking about two different simple uses, simple terms, such as when you are transferring some amount or doing a transaction between two different hashes, those hashes are cryptography in play, right? So technically, when you're transferring one Bitcoin to a friend, you are using the person's public key, which itself means that the person will also be having a private key with that public key, right? And you also will be having a private key with that public key. Both of you will only be seeing the public key, and the private key will be used to get access to the wallet that you have, right? So with this in mind, so I'll end the poll and I'll close the poll. Great. Thanks a lot. So so that's where we are when we are talking about transfer of currency between two different individuals. That is also happening via cryptography because you are using private and public key combinations, right? That's asymmetric key cryptography. Once that is where one place where cryptography plays an important role. Another is the entire block formation. That entire block formation happens by solving a very difficult cryptographic problem, a very, very difficult cryptographic problem, to be honest. Why it is very, very difficult? Because consensus mechanisms we'll take a look at, such as proof of work. The basic work is to solve a very hard cryptographic problem. And that's not hard in terms of concepts. It's hard in terms of the number of combinations it might take to arrive at an answer, because you cannot decode what that cryptographic puzzle means. What you have to do is you have to increase a number we call nonce, and you have to just increase that number, and you have to hit and try. You have to hit and try millions of times before you arrive at at the answer, where you find that okay, now I have the answer. When a lot of people do that, one of them gets the first one to do that, gets the reward, which we call gets the reward, and in turn he's the called the miner, and after he does that, the entire block goes into the blockchain. That's how it works. So that is where cryptography plays a very important role. Another important role is in Merkle trees. Why do we call it an unhackable truth? We'll see to it. We have a slide on that. And so what happens? What happens is that when that happens, that cryptographically hardened is it's called cryptographically hardened because once it happens, once a block gets into a blockchain, if anyone else with a malign intention wants to roll back anything in the blockchain, he has to provide more work than what went in cryptographically securing that blockchain. That is why a lot of attacks in the blockchain network, in cases of blockchains, is theoretical, because practically no one is in a position to do that. Also, it's very idiotic to do something like that. Why? We'll take a look later. It's very idiotic to spend a lot of resources, more than what went in securing a block, just to roll back and maybe do something with those transactions. Because once you do that, the blockchain network itself loses its value. It's a very detailed concept. We won't go into it. You can read about it anywhere. But it's that simple. Do not attack blockchains unless you really want to be proven an idiot, right? So because it's useless, right? Excuse me. We'll also take a look at distributed consensus. This is a very important concept, and this is exactly entirely what blockchains are on also based on. Because unless everyone, because it is a decentralized network, right? Unless every node arrives at a consensus, the block formation cannot happen. With the block formation happening, the blockchain is not moving ahead. The system fails. Does not make sense to have it that way. So hence, as we can see that this is very important. Arriving at a consensus. Now, arriving at a consensus, you can see a very good example would be if you are quarreling with your wife, even arriving at a consensus while you are having an argument with your wife is such a difficult method. I don't know. I don't have a wife yet, but I presume that, right? And if amongst two people, it is such a difficult and time-taking and pruning concept. Just imagine if what arriving at a consensus would mean when we are talking about maybe 200 different nodes scattered across the globe or the country. We are not even talking about 210 nodes in a building, and you have no physical approach to any of the nodes. It's all about consensus, arriving at a consensus in a distributed network where you will face latency. That is one big problem. Might not sound a lot because today networks are so fast. Think about a decentralized network where thousands of transactions are happening, and you are a node sitting in India. There's a node sitting in San Francisco. You have to make sure that once you've written your data, that gets propagated, that gets populated across all the ledgers around the world. France, Germany, England, someone maybe a node in Antarctica, one node in San Francisco, California, everywhere. You have to understand that it's not a very easy network that we are talking about. It will face latencies. You face latencies. Why are CDNs? Why are CDN content distribution networks available? Why do you use them? Akamai, Cloudflare. Why do big companies, why do servers use these kinds of services? Because these CDNs are placed at places such as maybe one CDN would be near to me in Mumbai, one CDN could be near to you in San Francisco, one CDN could be in England. So what happens is when I am accessing a server, I'm accessing a website that is hosted on a server in San Francisco. For the first time, someone has unmuted. So is there a problem with my voice or anything? Is it good to go? Can someone voice break? All right, voice break.
Yeah. Everything is okay.
Okay.
Abhishek, everything is okay.
Okay. All right. Now it's fine. Thank you again, Seema ma'am. Thanks a lot. And thank you, ma'am, for confirming that it's okay. Where was I? So yeah. So that's what we are talking about. We are comparing a blockchain to a normal everyday internet usage, right? For the first time, I was in between the example. For the first time, when you are requesting a server, a web page from the San Francisco, that comes from the server in San Francisco. But for the next time, every time your computer does not go to San Francisco to bring the data back, what happens is it gets cached to one of the nearest content delivery networks, content distribution networks, whatever they're called, CDNs, near to you. Next time when you request the same page, the CDN near to you serves you that page. That's how latency is reduced. Otherwise, if you always had to request for a piece of data from San Francisco, from England, you would have faced latency every time. That is why for the first time, everything loads a bit slowly, right? If you're opening it for the first time. So just imagine this is you're doing once, and now with every transaction, the blockchain network has to make sure that the information is propagated across all the nodes placed anywhere. Maybe once Elon Musk goes to Mars, one node could be placed in a colony in Mars. What will you be doing? So just a note. The founder of the father of the internet, Vint Cerf, after creating internet, he's now working on an interplanetary internet system, networking system. So hopefully, if Elon Musk reaches Mars, we'll have an internet in place by then. But jokes apart, when the distance is so humongous, especially in the case of a distributed network, things go very latent, things go very bad. You face a lot of latency, right? So that is why distributed consensus is a very important topic. Arriving at a consensus at a position where the consensus mechanism is fault tolerant. Fault tolerance is a very important concept in a lot of complex systems. If you and 80% of your faculties, you must be knowing way better than what I do. So who does not, you have to read about it in deep, what fault tolerance means and how to build fault tolerant systems, and what classes of faults you have to take care of. And but that is important as a concept, because a blockchain network has to be fault tolerant. at least to a particular class of faults, right? We'll take a look. We'll take a quick look at a very important. So I think my slide has not got updated, but there was another point. So we'll take a look at a very important concept called Byzantine fault tolerance, and what that means to be BFT enabled, to be Byzantine fault tolerant. That's a very important concept. And going ahead, we talked about mining yesterday. Mining is that process where you solve a cryptographic problem, and then your block of transaction goes into the blockchain, right? With that, we move ahead. Merkle trees. We have a slide on that. Very important concept. This is what makes blockchain unhackable. Because of any change that happens, the Merkle tree gets changed. Once that Merkle tree gets changed, everyone in the network knows that there's some problem and where that problem originated, right? We'll take a look at that beautiful concept. All right. And if you're having any questions, you may please keep them for now. We will take it at the end, because yesterday we were taking questions in between, and it didn't allow us to complete the class in time. All right, primary question one, what happens after you initiate a transaction? Just a second once. I had some questions. All right, okay. So what happens after you initiate a transaction? Let's go very slow, a bit slow, and see what exactly happens after you take out a transaction, do a transaction. You initiate a transaction that I want to send $10 from my wallet to my friend's wallet. You broadcast that to the network. What happens after that is that your transaction, this $10 transaction, has not been processed yet. Your friend has not received the $10 yet, or even after he has received it, you can't confirm it to be confirmed, because anything can happen in between. What can happen? We'll take a look at. So what happens is you initiate this transaction, it goes into the mempool, a concept called mempool, which is basically a memory pool of transactions. So all those transactions happening go into a mempool, that storage space called a mempool. Next, what happens is that the miners, who are very important part of a network, a blockchain network, what they do is they pick up transactions from that mining pool. Based on what? Primarily based on the transaction fee that's attached to a transaction. Because apart from, so these are intertwined, interlinked concepts. When you mine a block successfully, when a miner mines a block successfully, he gets a reward in return. In the case of Bitcoin blockchain, currently you are getting 6.25 Bitcoins as a miner in return after you successfully mine a block. And this is, why do you get this? Because you used a humongous amount of resources in solving that cryptographic problem, finding that answer, and broadcasting it to the network, which would mean that you are mining this block and you are adding that block to the blockchain network. You spent a humongous amount of resources. Yeah. So exactly. So that is what happens technically there, and so that process gives you a reward. Currently, that's 6.25 Bitcoins. Just 20 days back on 12th of May, it was until 12th of May, it was 12.5 Bitcoins. A halving happened. It happens after every 3-4 years or so. And so now it is 6.25 Bitcoins you get as a reward. All right, we'll move quickly, a bit quickly. And okay, so where we were at choosing transactions from the mempool. What happens is that when you're picking out transactions from mempool, you take a look at the transaction fee that's attached, because apart from getting the mining fee, reward fee, what the miners earn is the transaction fee that is attached with all these transactions. So if I'm sending you $10 and I'm attaching a transaction fee of $2 with my transaction, and my friend is attaching $0.5, I would get a better preference, because everyone wants to earn money, right? So this is how the transactions are chosen. That's what happens after you to initiate a transaction. Now, if you take a look at, after that, how does a block get decentrally added? For that is where distributed consensus is required, right? We'll take a look at distributed consensus next, because when you have a block of transactions, and you are finding you've made a block of transactions, so every miner can pick random number of transactions, right? It does not have to mean that you both, two people as a miner, are choosing the same number of transactions from the transaction pool. because you're mining it together, right? At the same time, because you don't know what the other one is choosing, and there are maybe thousands of transactions in the transaction pool. So you can be random at picking your transactions, or you can pick them based on the mining fee. It can be anything. Once that happens, once you solve that problem, you broadcast it to the network that I've got the solution to this problem, and now I'm calling it out that I'm mining this the block. When everyone else says that yes, you are the one who has found it because you have been the first, and that is where sometimes the problem comes, that at the same time someone else might have also mined it, because it's a cryptographic problem. It could happen that two different miners arrived at the solution at the same time. What happens at that, we'll take a look at eventually. It's a different concept of uncle blocks and all of that, orphan blocks and all, but we'll take that's a bit out of scope because it's not in the basics. So so to actually get a block decentrally added into a blockchain network, we have to arrive at a distributed consensus, which Wikipedia says that it's a fundamental problem in arriving at a consensus, especially in a system that multi-agent or multi-node spread across an entire network over the globe. The point is to arrive at a consensus in the presence of a number of faulty processes. Those are the faults I was talking about, right? And this usually needs every node to agree on some set of protocols, some set of values at the same time, to understand that yes, we are all talking the same language, right? So how does that happen? So that's how it happens actually. So I think we'll be covering consensus. So this distributed consensus happens using consensus mechanisms that a lot of blockchains use. One of the most important concepts of blockchain. Someone has unmuted it, so am I clear? Someone's mic is unmuted.
Yes, sir.
All right, thank you so much.
Yes, sir, you're clear.
Yeah, thanks a lot. And all right, so that's how we will take a look at consensus mechanisms. They are important and very important concepts in blockchain. That's how the blockchains work actually. And and using that only, people arrive at a distributed consensus, a consensus in a distributed network. This is why it is important. We'll take a look at another concept as we discussed. After that, we'll take a look at the consensus mechanisms. So, so as we were taking a look at what happens, how it gets decentrally added, and how is it secure, and how can you not roll back, and why Merkle trees is a very important concept in that. Why it doesn't make it the unhackable truth of blockchain networks. What Merkle trees means is that every transaction it's all about creating hashes for the entire network. So what happens is, so you can see in the diagram, what will happen is transaction A, transaction B, transaction C, transaction D are all nodes, are all leaves of this entire tree, right? These are all leaves. What will happen is that if you're a leaf, all the transactions that you have, you will combine to make one hash. So transaction A and transaction B will combine to make a transaction AB, right? A hash AB, right? Similarly, C and D will be combined and hashed. Hashes of transaction C and hashes of transaction D will be combined to make a hash of CD, right? Again, this hash of CD and this hash of AB will be combined to make another hash, right? Which is hash even beyond this, hash AB and hash CD. These both will be if these are the last nodes, either if they are in the tree, they will be made another hash, and so on and so forth, unless only one node remains, which is the root of the tree. When you reach that root is called the Merkle root. That root is called the Merkle hash. What happens is that this Merkle root is a hash, this resulting Merkle root is a hash that which contains the individual hashes of all the nodes and leaves on all the sides, both the sides of the tree, the Merkle tree, right till the bottom, right? It's a very bottom up approach to create a hash. Now you can imagine. So if you know about hashing, and 80% of you would definitely be knowing about hashing because you are faculties. So a hash, once a hash is made, so every time one particular value will give you the same hash, especially in systems like SHA-256, SHA-12, you will get the same hash. But if you even change one character in the data of which you are making the first hash, that hash will be entirely different. It won't be like if a hash contains 36 characters and the last character is A, and if you change the hash was of a transaction, and if you change just one digit in the transaction, only the last digit will change. It is not like that. The entire hash will change. The entire hash will be completely new. You cannot guess what kind of change will be reflected in a hash if you change anything in the underlying data. Very important concept, and this is the reason why Merkle trees make it unhackable. They give you the unhackable truth to blockchains, and everyone gets to know if something is if there is a problem anywhere. If a node is maligned, if he's trying to change any transaction, roll back any transaction, that is where you get to know that, right? So what happens is, if you're changing something from transaction A, the hash of the hash AB will change. If the hash AB is changed, the hash of AB and CD combined will change. And this way, the entire effect, even changing one digit in one block in a transaction, is changed. It will result into a change across the Merkle tree, the Merkle root. And if the Merkle root changes, everyone in the network gets to know that there is some major problem. There is some problem that someone has tried to tamper with the data. Once that happens, people get the hint of it. People disregard the network. People know that the network has been hacked or something has happened. And this is why I called out that anyone trying to deploy resources more than what went in building those blocks just to roll back a particular transaction is going to be an idiotic choice. Because when you do that, the network gets to know easily. Once the network gets to know, they just leave that network, they fork it, and they continue with a new network. This happened with Ethereum as well. Ethereum got divided into Ethereum and Ethereum Classic, right? So these things happen a lot. So why did you even spend so much resource if the original network didn't even exist anymore? Right? So that's why it's an idiotic option. So that's what Merkle trees are. They provide a means to prove the integrity and the validity of data. They require little memory or disk space, as the proofs are very computationally easy. So these can be built very easily, because calculating the SHA hash of any number is very easy. It's very fast. But any change in it, but decrypting is not possible, because hashes you cannot decrypt. Decryption is a different story, but if these are hashes made with these algorithms, you cannot decrypt them. You can only hit and try and then find out a solution which again matches the same hash. What data will match the same hash? This is exactly what miners do. When they are mining, they are just hitting and trying a value that will match, give the same hash, right? Their proofs and management only require tiny amounts of information to be transmitted. So can you imagine, with very small storage, with very fast operations, you are able to secure an entire blockchain network that is spread across the globe. This is big power. This is humongous power in your hands. You do not need to keep records and records in store and in RAID databases, RAID servers, just to make sure that it is unhackable. It's just a small storage space and a very fast calculation. All right, a lot on that. So before going to the consensus mechanisms, we'll take a look at myths of blockchain. Yesterday, we took a look at myth number 1 and myth number 2. We won't revise that. You missed it. And if you were not there, we'll take a look at myth 3 and myth 4. Myth 3 is that blockchain is a truth machine. See, it's not that. Blockchain is not a. People believe that if blockchain is so secure, so transparent, so public, so anonymous, and all of that, blockchain is a truth machine, right? It's in computer science. It's all about garbage in and garbage out. If you give it garbage, it will give out garbage to you, right? Blockchains per se have no way of knowing whether a particular piece of data obtained from the outside. So this is particularly for those blockchain systems which rely on data from the outside, which rely on external data. If the data that has been fed is incorrect, how will you get to know if the flight timings or if the mutual fund rates are fed incorrectly to the blockchain? It's common sense. How will the blockchain know that what I'm calculating is incorrect, right? Another myth is that, just a second. Another myth is blockchain is free. So people believe that just like Linux, people started that it's open source, it's free. It's open source and it's free. So everyone moved away from Windows to Linux, whoever wanted to. Blockchain is also open source. Blockchain is free. No, blockchain is not free. Many people believe that blockchain is free, but setting up a network like blockchain, which is so distributed, spread across nodes, maybe not even in a building, it's across the entire state or the entire country or even the entire globe. It is not free. Setting up a blockchain network, even if you're using cloud services or ready-made blockchain as a service given by these cloud services like Amazon, Microsoft, Azure, these are not free. They will charge you. They charge you a lot, and setting up a blockchain network yourself definitely is a very pricey operation. That is why yesterday I put a lot of emphasis on, if you do not feel the need, if you think before applying or implementing blockchain in any use case that you have, if you're thinking that your every other use case that you have, you can use blockchain in it, possibly it could be possible that it's an idiotic idea. Just make sure that whatever you are implementing blockchain into needs the core characteristics of the blockchain. If you're dealing with a sector that's filled with corruption, collusion, fake receipts, all of these frauds and all, probably one of the best areas to implement blockchain. If it's not, you're trying to build a to-do app and you're trying to do that on blockchain, why will you do that? I mean, you are not going to lie to yourself or collude or corrupt or create fake to-do items in your own to-do list, right? Why will you do that? So if you're implementing a to-do app on blockchain, it is going to cost you. A free to-do app will suddenly become a very costly to-do app. It does not make sense. It's idiotic, right? So with that, before proceeding, next is before proceeding, let's please take a quick poll. Please, everyone, if you are not sleeping, if I'm not that boring, please take a look at this poll and please answer it. It would be really great. I'm trying to launch the poll. 1 second. Divya ma'am, are you able to see a poll?
No, sir. No, sir. There is no poll.
Can you, if Divya ma'am is there, can you please launch poll number 1, which is the use case poll?
Hello?
Yeah, hello.
Hello? I have to talk with them right now. Okay.
Hello. Okay, if this does not launch, we'll skip it altogether. Just try for a bit.
That's okay.
I don't know what's happening with the poll system, but let's not try anymore. All right, it's not launching. Let's forget it.
Okay, so you start.
Yes, it's starting. Yeah.
So you can start.
Yeah. All right. Moving ahead. Okay, so this is a video I wanted everyone to see, because this will pretty much give you a good revision of what we did yesterday, but within hardly 3.5 minutes. So we'll try to take a look at this. If it works, it does not work, it will. Are you able to see my presentation? Are you able to see the video?
No.
Okay, I got it. Why you are not able to see the video? Let me know if you're able to see the video. Excuse me.
Yes, sir, it's going to start, I think.
Yeah.
Buffering right now, it's buffering right now.
Yes, I'm waiting.
When you want to buy something normally, using your normal bank card, this...
Oh, okay, something happened. 1 second.
So this is great. It's
When you want to buy something normally, using your normal bank card, this is what happens. I give my card details to the shop. The shop...
Is the video audible and visible both?
Yes.
All right.
asks the bank if I'm good for the money. The bank checks its records to see if I've got enough in my account. If I do, it lets the shop know. It updates its records to show the movement of money from my account to the shop's. Oh, and it takes a little cut for its trouble. Now, if you wanted to remove the bank from that system, who else would you trust to keep those records and not alter them or cheat in any way? Well, I wouldn't trust you. I wouldn't trust you. In fact, I wouldn't trust any single person, but I might trust everyone. The idea is you don't have a central record of transactions. Instead, you distribute many, many copies of this ledger around the world. Each owner of each copy records every transaction. So, to buy something using cryptocurrency, I give the shop my details. The shop asks all the bookkeepers if I'm good for the money. The bookkeepers all check their records to see if I have enough. If I do, they tell the shop, and then all update their records to show the movement of money. So there's no way that a forged transaction can make it in. If I try to alter a ledger, it won't match all of the other copies, and it gets rejected. Oh, and one of them, at random, will be given a reward of some newly created cryptocurrency. This is how cryptocurrencies work. And remember, all of these bookkeepers, all of these ledgers, they're not actually people, they're computers. Lots of computers.
All right, with that, I hope this video has given a very good idea of what exactly blockchain means and what it means when you're using a decentralized kind of a technology to transfer funds or to do any kind of transaction between two parties, right? I'll just switch off to. I think the presentation should be visible now. So people have asked that where's the practical? So as I said that I just saw that 80% of your faculties and then students and all, and people have written to me that basics is still not clear. Basics is important. I can immediately, as you could see, that the other tab that was open was of the practical of the Etherscan that we were about to see. But if I just jump up there, I'm unsure how much you will understand when we'll be discussing about hashes and all. Just bear with me for some time. If you're thinking that we might not be able to cover all the topics, which might be true, but we'll make sure that we cover that tad bit of practical approach that I've promised at the beginning. But I don't think that doing it abruptly right now is going to be a good decision. Please bear with me for some time. All right, let's move ahead. Great. So we are on consensus mechanisms. Let's do one thing. Let's jump a bit. Let's postpone consensus mechanisms for now. All right. I've jumped at least 20 odd slides in between. So definitely have not covered a lot of basics, but we will cover that. Consensus mechanisms we will cover. As I said, it's a very, very important concept. I won't let you all go without explaining to you what consensus mechanisms are and how they operate and how they play a very important role. But just to because a lot of people have commented, so let's go ahead with a very basic but very neat and very cute kind of a practical session that we wanted to cover. So we are jumping straight into Ethereum. So there would be a lapse of a lot of concepts. Ethereum is a public blockchain network. It's a generation 2 network, but we'll cover generation 2 later because this slide was after we discussed generations of blockchain. So what happens in case of an Ethereum blockchain is that not only can you just transfer funds, Ethers, the native currency is Ether, but you can also, on the other hand, write code on the blockchain. That is a very important concept because writing code came for the first time with the Ethereum blockchain. Other examples are Neo. Neo also gave you the option to write smart contracts. That's a pieces of code which you write on the blockchain network directly, right? So with that in mind, so there's an anecdote that I wanted to share with you all. Many people don't even believe this because on December 2, 2017, a digital cat, that's it. You can see it on the bottom of the screen. That's it. That's how it looks. That's all. It's nothing more. It's not even a real cat. That thing was sold for $117,000 worth of ethers, of course, but this is real money. Even if you're transacting in Ethereum, this is real money. Someone paid $117,000 to someone else to get this kitty from him. Where? Nowhere. It's just like Pokemon Go. You just throw a ball. Where do you throw a Pokeball? You throw it inside your Pokemon Go app. That's it. And you catch your Pikachu. It's the same. And then you grow it. Then you make it breed with another cat, and that's all. That's all it is to CryptoKitties. But CryptoKitties in December, sometime in December 2017, had congested the Ethereum network to an extent, as you can see in the graph below. CryptoKitties really started with a very meager number of transactions. A very low number of people were actually exchanging kitties, breeding kitties, growing kitties, and all of that, which you can see at the beginning. But later on, suddenly something happened, and at a time there were 11,000, 12,000 pending transactions in the Ethereum network. As you can see, as we just discussed, that when are transactions pending? Transactions are typically pending when miners don't have a lot of motivation to pick your transaction to mine it, because it does not have a lot of a good quantity of mining fee attached to it, right? Or there are a lot of very small transactions which have no mining fee to it. So these things become difficult for a miner as well to sustain themselves, and they are not very interesting for a miner to carry out. So that's what had happened. A lot of the pending Ethereum transactions after CryptoKitties release was this at that time in December. And because of this, because the blockchain network is the same, so people who have nothing to do with kitties, who have nothing to do with CryptoKitties, they were also not able to transfer ether between one another. They were not able to do anything, because everything, as I said in the beginning, everything is a transaction, right? On the Ethereum network. You don't bifurcate it into any other type, right? So we'll take a quick look at what this was. This is a good Ethereum anecdote, and we'll take a look at what it actually was. And then we'll try to find the same thing on the Ethereum blockchain publicly. So this was the hands-on that was to be covered today. And we'll try to see that what all we can see. To be very honest, even I have not taken a look at the Ethereum blockchain for a few months now, because I'm not working on Ethereum. But it's a public blockchain. If it's for public, then we should be able to see a lot. Are you able to see my screen? No, right? Now you should be able to. So currently you're seeing that the program. Please note a lot of important concepts, even though these are very cute kitties, but they also teach you a lot of important concepts in blockchain. One is they run on smart contracts. What are smart contracts? We'll take a look later, because we had to skip it. They were in the slides in between, and detailed was for day 3. And also, not only they run on smart contracts, these things, CryptoKitties, applications like CryptoKitties, applications like the scanner itself, the Ether scanner itself, these are all decentralized applications. They are talking to the blockchain directly, and they are called dApps. Like, apps, you build Android and iOS apps. These are decentralized apps, dApps. And these talk to the blockchain directly and look like general apps, but they talk to the blockchain directly. Underlying technology is completely different. dApps we were also supposed to cover. So this was the kitty. So see, another very important concept. If you remember, I just said that the first transaction, the first block in a blockchain is called the Genesis blockchain. Right? Everyone is able to view my screen, right? Ma'am, can you please confirm?
Yes. It's okay.
Great. So yeah, I just come across this, that why is it calling itself a Genesis cat is because it was the first cat. It was in the first block of its own implementation, and definitely not the first block of Ethereum. But in any case, in any blockchain, the first block is always the Genesis block. When Satoshi Nakamoto sent 50 bitcoins, a transaction of 50 bitcoins, and sent it to Hal Finney, sometime in 2009, September, I don't know, 2009, right? That was the first transaction on blockchain, on the Bitcoin blockchain. And to be very honest, it was 50 bitcoins, and it was mined very easily. It was and the reward was also 50 bitcoins at that time, which is now 6.25 bitcoins. And so that was the first transaction. And the first transaction that went with it and the block that was created, it was the Genesis block. A very good anecdote is that Satoshi Nakamoto had put in a line in it, content in it, which read the headline, which was also same in a newspaper, in a very popular newspaper of that day. So this proves that it was not tampered with. The Genesis blockchain, the Genesis block, the blockchain, Bitcoin blockchain actually started out that day. It actually started that day because it matched actual facts. So that's what Genesis blocks are. And how are Genesis blocks different from any other blocks in the entire blockchain? Because out of the thousands of blockchains that have gone into the Bitcoin blockchain, how is it different from the Genesis block? It's because Genesis block is the only block which does not have a previous block's hash to take care of, right? So every other block, that is how you cannot roll back any transaction, or you cannot delete a block. You can't roll back a block, because every block refers to, links to, you've studied linked list, right? Similar concept. Every block links to the previous block, then that links to the previous block, and so on. Every block is related to the very first block in this manner, because the latest block has a hash. That hash is a part of the hash of the previous block, and so on, right? The hash is a part of the previous block's hash, and so on and so forth. And that is why any change anywhere, the latest block's hash will change. So that is how you get to understand that something has happened, right? So but in the case of Genesis block, it does not have a previous block's hash. So that is where it is manually created, and this is the only block where a manual creation is being done, is done, right? So let's take a look at this. So this was the dApp, and let's let me, I have to copy this. All right. So what we do is, I'm assuming you're able to view my Etherscan and not my PPT, is it? Can someone please confirm if you're viewing Etherscan?
Yeah.
Great.
Yes, sir.
Yeah, great. So what we do is, I just copied the hash. I had taken it out on the PPT. You can find it anywhere on the internet. So this was the hash. As we are knowing, everything is done by cryptography. So this is a cryptographic hash that was created, and this was the hash for this particular transaction. So what we do is, okay, so to give you a good background, this Etherscan that you are seeing, this is what the public blockchain looks like, because it's a technology, right? Right? You cannot see the technology as is. That's how it works. So so then people had to create a front end for it. It's the back end. So now the people have created a front end for it, and with that, people have given options to search via transaction hash, via block number, via token, exact token, or the Ethereum namespace. It's a different concept, out of scope of this course. So you can search it here, and this shows you everything. The latest, this Etherscan is what shows you the Ethereum price, which you can see that it's currently $239 a piece, right? Then the market cap is this. You can see the number of transactions, total transaction counter till now is 726 million transactions have happened till now, and that's basically 11.4. A very important concept, will come to this later. If you can see that this number, 11.4 transactions per second. This is what Ethereum network is all about. Ethereum network, or any kind of blockchain, public blockchain network per se. This is where generation 1 and generation 2 blockchains are failing. The scalability, even after reaching an amount of 726 million transactions, the scalability is so limited, right? This is a concept. Let's discuss it before actually seeing the blockchain in action. So people are not able to do a lot of transactions concurrently using any blockchain like Bitcoin or Ethereum, and that is the problem. Ma'am, are you saying something?
No.
All right. Okay. So so that is the problem. 11.4 transactions per second is not sufficient for you to use Ethereum in your day-to-day life. Like, for example, you cannot buy coffee with Ethereum yet. What will happen is that you go to a Starbucks, you want to pay for the coffee with Ethereum, what will happen is that because it is just 11.4 transactions per second across the globe, you don't know when your transaction will be processed. Hence, you will be waiting there for your transaction to be processed, to be picked up by a miner and get and put into the blockchain and then confirmed. And Starbucks would not know that how much to wait and when to create, when to make your coffee. This is why when you compare this with Visa, Visa is, I think, 1700 transactions per second. 1700 and 11.4. You can understand the kind of difference this is. This is nowhere comparable. That is why currencies like Ethereum and Bitcoin and all, it's a very important practical concept. If you're meeting that, this is a very important concept that Ethereum and Bitcoin and other such cryptocurrencies are not able to catch up with payment systems such as Visa and MasterCard, who have thousands of transactions per second capacity. And VisaNet says that they can go up to 64,000 transactions per second. That has not even been the need yet. Ethereum can nowhere go near that, right? So, all right, that was a very important concept we saw. We'll take a look. We'll just paste the hash here. One second, it's going a bit slow. I've already pasted it. There is some technical glitch. Please bear with me a second. Okay, seems my computer is hung now. Till the time I'm waiting for my computer to respond, I'll take some questions here. Kindly will you share the link to download Ethereum Ubuntu.ova file? I don't understand what you mean by that, because Ubuntu.ova are the virtual machine files. Ubuntu.ova are virtual machine files, as far as I know. I don't know how that comes with Ethereum, because if you are looking to install Ethereum on a virtual box, all right, okay. If you're looking to run Ethereum blockchain on a virtual box, then what you'll have to do is first install a blockchain, install a virtual box, virtual system as you do normally. And that's out of the scope of this course. And after you do that, you can download Ethereum separately. And how you can do that? You can just go to ethereum.org. I'll paste links in the class dashboard that I shared. That way you'll get the Ethereum, you can install it. If we have time, we'll see how to do that. Please tell from where to, okay, the hash has been pasted. Please tell from where to get the hash. To be very honest, everything is public. Matilda, Miss Matilda, this is all is public. That is what I'm showing. So I got this hash from the internet itself. I just made a Google search, CryptoKitty Genesis Kitty hash, and I got it. From there I took it, and if you're able to scar the entire Ethereum blockchain, you'll get it here as well. So we'll just do the search and see. Okay, first to cover basic concepts, then practicals to understand. Dr. Ejat Ahmed sir, that is exactly what I was trying to do. So we'll get back to that right after this. I don't know why it was not found. And my computer is hanging. Just please, this is a technical glitch. I can't do anything with it. Let's just see if we get it directly here. So I don't know why it didn't work. Oh, okay, okay, okay. I think this was the problem. Let's see if it works now. There's a space in between. Yes, we have it. Thank God we do. We didn't waste any more time. So as you can see, so this is practically seeing the public Ethereum blockchain, right? So let's take a very deep look. Now this is something that you all demanded. So please pay very good attention, because again, there are a lot of very important concepts which we are covering by diving deep into this right away. And so we can see this is the transaction hash that I had originally copied. It is there. Status is success means the transaction was done, right? This is the block. This was the block number in which this particular transaction was there. All right. Okay. And we also want to see the kitty, right? All right, so this is the kitty. You can see that the token transferred was this kitty. You can match that with what I showed. The kitty was the token. Kitty had token ID 1. It was the Genesis kitty, and this was the transaction. So the transaction data is this. It happened 916 days ago. It was from this. So this is what I was saying. In a public blockchain like Ethereum, this is the transaction hash. This is the public key, right? This is the public key of the sender. This is the public key of the contract in cases of smart contracts, or if you're doing a peer-to-peer 1:1 transaction, then this becomes the public key of your friend whom you're transferring the money to. So that's it. By looking, so this is public data, but by looking at this long cryptographic public key, you cannot make out whom this address belongs to, right? You cannot make out who actually owned this particular kitty, right? That is what transparency along with anonymity means. We'll see. Okay, all right, that's it. Okay, we'll come to this, and great. We just saw that.
Hello.
Hello. Yes, ma'am.
Abhishek.
Yeah.
Abhishek.
Yeah, ma'am.
Actually, the content of the screen is not visible, not clear. I'm not able to read what's written.
I'll try to zoom in a bit and let me know if it is visible, because that's all I can do. Is it better now?
It's better now.
Can you read these 916 days and all of this? To, from, all of this?
I can read transaction hash, status, block.
Right. Great. Great. So that's almost. So you don't have to read all of these cryptographic public keys. That's of no use. Main thing is to read. I'll scroll a bit slowly. Main thing is to read these keys, because that is where it says that when this transaction happened, which block number it went into, which public key sent this, who was the owner. You don't know who was the owner, but which public key was the owner of, which wallet was the owner of this particular Genesis kitty, right? And the status is success. One very important term that I had used in between was that you have to wait. For example, after you're paying for your coffee, you have to wait. Starbucks has to wait for a set number of confirmations. In the case of Bitcoin blockchain, the network has accepted that after 6 confirmations, you can say that, okay, your transaction was processed successfully. So that confirmations is this. You can see that it has been written that this particular transaction has got these amount of 5.5 million block confirmations. What this means is that after this transaction took place in block number 4664261, which I hope you can read, after that block, there have been 5.5 million blocks to come till now, till as of date, till this moment. So this means that, and why is it called block confirmation? Because after every block is added to a blockchain, the transaction that went into a particular blockchain gets confirmed again and again, that it is further down the road. Why it is called confirmation? Because now if someone at this point has to change anything in this kitty transaction, which happened 916 days ago, 3 years back, anything in this transaction, he has to exactly go 5.5 million blocks behind. So this is, of course, you can hear it. It's pretty impossible. It's idiotic. And so that is why people wait for 6, 7 confirmations, because so that they know that at least after your transaction, there have been 6 or 7 further blocks that have been there. So now to do anything with your transaction, you'll have to go 6 blocks back, which makes it further and further difficult. So this is, I hope this is a concept you all are understanding. One of the most important concepts, why blockchain is so secure, why people don't,
Hello?
yeah, hello?
Hello. Hello.
Yes,
Can
ma'am.
you share the URL of this so that participant can also open it? Actually,
Yes, of course.
is it possible for you?
I can try to share it in chat. I can do it immediately. Yes.
It's
So I'm sharing it on chat, but to be very honest, I would have loved if you would have gone to etherscan.io. Every one of you would have gone to etherscan.io. Keep this website with you. I'm pasting it here, but I hope that link works. Keep this website with you. I'll upload it. I'll also write it down, explain it in the classroom dashboard, which I shared. I think I shared. I'll share it. And you should keep these websites, etherscan.io. Then there's a Bitcoin Explorer called blockchain.info. It's a Bitcoin Explorer. There are more explorers available in the market as well. These are the popular ones. So these are the websites you visit to actually take a look at the public Bitcoin and Ethereum blockchains. This is why it is so important, because this is how you get to take a look at such a huge treasure trove of data that went into a transaction that was done 916 days back. This was done 3 years back, and you can still see. Can you right now call a bank, call ICICI Bank, call Axis Bank, and tell and ask them that give me all the details of the transaction that happened between, not even between me and another person, but that happened between my friend and his friend just as of yesterday? Can you do that? You cannot do that. Nor can you see that whether a bank like a bank A in India transferred maybe 50,000 crores to another bank in India. You cannot know that. What happened in between? Were they colluding on something? Were they doing any fraud? This is exactly the problems that a centralized system faces. Believe me, this is where you have to understand blockchain. Writing smart contracts, building decent applications come way later. That is when you are about to become a blockchain developer. But to understand blockchain, these are the core concepts. These don't happen in your everyday life. I can bet on that. Because in everyday life, you're dealing with very centralized systems where till the time you're listening to me, you may please also open Etherscan and check, because I pasted the link there. And Shival Chadda has been kind enough to give the block of the block number as well. So you can go into that block and you can see all the transactions that happened alongside this kitty transaction. So you can just figure that out till the time I'm explaining this very important concept, that whenever this happens, you have to be ultra sure that you have to understand that these are not the concepts that you see every day in your everyday life. You're surrounded with very centralized systems. Everything you do, starting from waking up till going to the bed at night, is mostly dependent on centralized systems. And this is the kind of transparency you don't have in centralized systems. You cannot do this. I am seeing a transaction that happened 3 years back between two completely anonymous entities situated in a different part of the world. I am able to see it sitting in my home on the internet in a public browser, and you all are able to see that. So this is the kind of information that we get. What is a forked block? Deepak will take questions later. We won't take it now, because anyways we do have less time. Forked block I had mentioned in between as well. We'll cover it later. Let's see some other, just because we are covering practicals, let's see some other. So, okay. This was, if you can see this, the two was a smart contract, because this was a transfer between a kitty. This was a transfer of a kitty, which was governed by a smart contract. What are smart contracts? You all asked me to skip, so we skipped it. They are programmable codes on, they are programs written on blockchain, deployed on blockchain, and they run when a particular condition is met. Only difference between code run on a centralized server and on a blockchain is that this kind of code, once it goes online, you cannot change it. So that is why auditing a smart contract and all, and testing a smart contract is very, very important, because once anything goes in a smart contract, you cannot change it. To do what you'll have to do is you'll have to deploy another contract, and doing everything on the Ethereum blockchain. Please listen, doing every transaction on the Ethereum blockchain costs you. It costs money. So if you're planning to just go about writing down your to-do on the Ethereum blockchain, you are going to be taking up a very idiotic project, because it's going to cost you a lot. A free to-do app will become very costly for you. See, we can see that the transaction fee was $0.08 at that time. So you can see that it costed money. So every transaction generated this transaction fee, and this is the transaction fee that goes to the miners. If this is very less, miners don't have an incentive to pick that up. If this is high, huge. There's an anecdote. Someone back in 2000, I don't remember the year, 4 or 5 years back at least, they did a transaction of I think 1 BTC, but gave 30 bitcoins, 1 Bitcoin transaction, but gave 30 or odd bitcoins as a transaction fee. That is a humongous transaction fee you're paying, because that is not going to go to the person you're transferring the 1 Bitcoin to. That 30 bitcoins will go to the miner, and there's no reason you will put 30 bitcoins transaction fee for transferring 1 Bitcoin, right? So, but in such cases, a lot of such cases have happened, but in such cases, the miner or the mining pools have been kind enough usually to return most of that. Out of 30 bitcoins, maybe they would have returned 29 or so bitcoins, or 28, 25 bitcoins as a good faith, sign of good faith. But you have to be very careful, because this transaction fee, you have the capability to set this transaction fee when you are doing a transaction. So if you by mistake, if you instead of giving $0.08, if you give $8, $80, that thing is going to go. And once that goes, blockchain is immutable. Once you send this, you cannot take it back. If you've sent 30 bitcoins as transaction fee, it's gone. Unless the other person who's receiving it is kind enough, the miner who's receiving it is kind enough to send it back to your public key. He doesn't even know you personally. You don't even know them personally, but if they're kind enough, they'll return it to you. Otherwise, it is gone. Once you click that confirmation, it is gone. Blockchain is immutable. You cannot roll back anything once you do that. Be very careful while transacting on blockchains, while writing programs on blockchain, and doing anything on blockchain, right? This was the value that was transferred. So I think I had mentioned that on the PPT as well. So let's check. All right. So you can see estimated value of time of the transaction at that time was $113,000. So I wrote on my PPT it was $117,000. Clearly, I wrote an incorrect number, but that number was corrected by the public data that we just saw live. This is it. You can now, sitting now, know that the value of the transaction was $113,000. But then it's a very funny thing that you caught a kitty, you transferred a kitty, you paid $113,000 for a kitty. It's just like paying a few $1,000s for catching a Pikachu on your Pokemon Go. You won't get it anywhere, right? That's all. It's a game. So let's see what is there when we click to see more. So this shows, yeah. So this shows a lot of technical details. Gas used, gas limit. Gas is the transaction fee, fee that goes in. It is in terms of gas. You have to specify particular gas that goes with every transaction, every Ethereum transaction. That is what we call gas. And there's also gas limit, which puts a limit on how much gas can the you can. All right, I'm getting some feedback. So that is where gas is, you put a limit on the gas so that the transaction does not use more than that, right? So the nonce is the position of the, we will not get into this because this again, we have missed these concepts earlier because when we were doing consensus mechanisms, and there are two kinds of nonces. One is just the incremental number that you put while you're finding the answer to a cryptographic problem. In another case, nonce is just it's just used in creating the cryptographic hash, right? We'll see about it in detail when we'll specifically be doing the Bitcoin, the Bitcoin blockchain. We'll be taking a look at the Bitcoin blockchain. All right, so that's mostly it. There's a host of other information that all other transactions that happened. Someone gave the link to the block. Okay, so this is the smart contract. If you see the smart contract ran a function called auction successful. It gave the token ID, it gave the total price, and you can view the source code of that. If you're able to see my screen, you'll view the source code of that contract as well, and all the details, right? From which address, the transfer. This is another function in the smart contract, but we've skipped all these concepts. So definitely a lot of you might be knowing about these things, so you might understand. But a lot of you, I believe, won't be able to understand because we have skipped these concepts. So I'll try to quickly go back to the slide, and I'll see that if there's anything else. Yeah. So in the Etherscan itself, these are all the options that you get. You can view the transactions that are you can view the pending transactions. You can view blocks that are happening. You can view forked blocks. So someone just asked for forked block. You can go here and check. We'll take a look at fork blocks later. Fork blocks, usually people fork blocks when either it's a soft fork or it's a hard fork. You do a fork when either you're dissatisfied with the current protocols of the blockchain, or some hack or a kind of thing happens and people just fork a blockchain and take it away. And that starts running separately in parallel. Uncles are a different kind of blocks, where we were talking about two blocks coming up with the two miners coming up with the solution to the cryptographic problem at the same time. Only one of them, the block from one of them would be accepted into the blockchain, right? What will happen is that both the blocks will go into the blockchain, but whenever someone else, the next block will be created, it will go into either of those blocks, right? Either of those, in front of either of those blocks. So what will happen is, after some time, that one block will be hanging out, and the other block will have a longer chain after it. So anytime the network knows, the protocol, the Ethereum protocol says that anytime, whichever the longest network is, the longest chain is, consider it as the truth chain, and every other block will be discontinued. Right. Great. So these are the things that you can do. I'll quickly go back to the presentation. Can someone please confirm if my presentation is now will be visible? I hope my presentation is visible. We are in the last 10-15 minutes of the
Yes, it is.
We'll quickly go back and we'll see that if we can cover some topic which is important. We were at consensus mechanisms. We'll take a look at, we did this, we were at consensus mechanisms. So we will take a look at consensus mechanisms typically tomorrow, because this will take half an hour and we don't have that today. Please read these consensus mechanisms today if possible, because you can see them on the screen. These are the most important ones. And then there are further other consensus mechanisms as well. But mostly these are the things. After that, we'll quickly cover one concept called, okay, so all the concepts will take time. Do one thing, let's do one thing. This is the class dashboard. Please take note of the class dashboard. This is how it looks. It's a public page. Please, the class dashboard is free to use. And I'm just giving the link here. I've given the link in the chat. Please use that. The class dashboard is the best place to read anything that is not covered in the class, because believe me, the kind of content I have prepared for this course is going to, so I have overshot the runway with that content, because there's a lot of content, and so we cannot cover that in time. We still have one more day, but there's a lot to cover, especially hands-on. And you can see that even taking a look at Etherscan took us so much time, and also a bit of technical glitch. And you can understand that when I'll be opening my terminal, what kind of glitches and what kind of delays and latencies it will happen at your end too, because we'll expect all of you, all 200, 300 of you, to open your terminals as well, which will be possibly tomorrow. We'll try to start with that after consensus mechanisms. But please visit this dashboard so that you get all the information that I want to convey, be it regarding any announcements, be it regarding any further studies to be done, any extra materials to be read. And there's a WhatsApp group. Please, if you join it, do not spam it, because it's all educational content. Do not send any marketing links or anything there, because it just kills the show. And you can comment on the dashboard if you feel like. I'll answer it there. And apart from that, a very important thing for me would also be if you can give me feedback entirely, because I'm pasting the link of that as well. This feedback will actually take you 10 seconds. It's an anonymous feedback, just one question, 2 questions. And this helps me a lot. Yesterday I received beautiful comments, and I have tried, like one of them was to be slow while speaking, but I think I was fast today. Believe me, if you heard me yesterday, it would have been further faster. And which link is not working? Yesterday link was not open yesterday. If you face any problem, please write to us via email. We'll share the links anyways. Okay, to the entire class. Okay, before closing off, ma'am, before taking questions, I have a couple of questions to give. If possible, we'll try to run that. If it does not run, we can, yeah. So there's a poll on your screen. All right. So we have 10 minutes now. So we'll close. We cannot start consensus mechanisms, to be very honest, because that is a big deal. And we had to skip to the practical part. So we had to skip something. We will have to skip something. The time is so limited. So the question is, Etherscan is what? We just took a look at Etherscan. Etherscan is what? I'm seeing that I'll wait a bit. 50 of you have answered till now. I would really request that some of you must, if you know the answer, that some of you must be facing a problem, big problem between two options there, because I've not left it multiple choice. I've left it. I think I've left it radio buttons. So Miss Shweta Gupta, where to go in dashboard? Nowhere. It's there. You can see the screenshot here. It's there. So if you want to take a look at any text that is required, you can go into the required text that you see there. For assignments, we'll post a quiz, very short quiz for your interest later tomorrow, after the class tomorrow. There's the entire schedule there. The WhatsApp group is there. There's a link to get the certificates after the course is over. So because the certificates are being provided by a US-based organization called ODEM. They are the ones who are providing the certificate on the Ethereum blockchain. Okay, I believe after this Etherscan hands-on, I pretty much believe that you are in a good position to now understand what it would mean that after tomorrow's, whoever is attending the FDP entirely, after tomorrow, when you will be getting that certificate on the public Ethereum blockchain, what that would mean. You will be able to go to Etherscan and will be able to check it. And you can give that same hash, transaction hash, to anyone across the globe. And he'll be able to check it as well. They'll be able to check it as well. That is the power. And that is what we are providing with this course. We hope that this is happening for the first time with you, actually. So a lot of people have answered, still 50% to go. All right, we have pretty much got a lot of answers. So the 4 options were Bitcoin Explorer, locally run Explorer, Ethereum Explorer, and a dApp. Most of the people have said Ethereum Explorer. A lot of people have said Bitcoin Explorer as well. I'm pretty much sure that Etherscan, though a lot of Bitcoin Explorers have started providing Ethereum exploring as well. I'm pretty much sure that Etherscan, I'll have to check as well. I made this quiz, but I'm pretty much sure Etherscan is not providing Bitcoin exploring right now. It's an Ethereum Explorer. Some of you have said dApp as well. That's true. It is a decentralized app as well. Any kind of application that is talking to the blockchain is a decentralized application. It's using decent technology, right? So the actual answer is it is an Ethereum Explorer as well as a decentralized application. So all of you were right there. 67 and 80% were right there almost. That's great. You are listening. So if you're having a problem with attendance, you can please fill the form that Pushpa ma'am has shared. Even not, if you have used your correct email address or your name, particularly to join the lecture, we will have your attendance. We'll take it, extract it from Zoom. So please make sure that you log in with your proper name and your proper email address when you're joining the class. All right. So I'll end the poll and I'll share the results. That's it. That's where we are. And again, please visit. I think we are done. It's 4:27 p.m. Let's take some questions. Pushpa ma'am, let's take some questions right now. And let's
Okay.
at 2:30 at 4:30. Pushpa ma'am, are you there?
Hello.
Yes, ma'am.
Hello. Am
Yes.
I audible?
Yes, ma'am. I have a lot of topics to cover, important topics, but we'll have to start on them tomorrow. It's good that we jumped and we took a look at the hands-on Ethereum public blockchain directly. I believe it was one of the most important parts of the.
Definitely, it's really very interactive.
Yeah. So that's how you get to understand that how public exactly the blockchain is, right? The Ethereum blockchain is, and also you get to understand that what will happen when you'll get a certificate on this blockchain. And as you know, anything that goes on the Ethereum blockchain costs money. You just saw that it takes a transaction fee with it. However, the organization, we are providing the certificates on the Ethereum blockchain public use for free. We hope you really make good use of it by putting it on your LinkedIn, right? All right, ma'am, I'm done. I will just
So,
slide. So this is the day 2 conclusion then. We have left consensus mechanisms, which is very important. We have left generations of blockchain, types of blockchain. We will cover these tomorrow. Apart from seeing smart contracts, hands-on, we'll open a terminal and we'll write a smart contract. We'll try to do that. Please install, please go to the dashboard and check what you have to install before coming for tomorrow's class. Everything will be provided there. Right. So that's what it is. And please visit the class dashboard. You'll find everything there. And that's it. Please provide this feedback to me. Ma'am, please take over. We can take some questions.
Okay. So there is any questions? If there is any question, you can write in chat box.
Yes, I have a question, ma'am. I see a question. So Bharat Sharma has asked that, as you showed in Ethereum site, if I can see a third person's transaction, even 3-4 years old, unlike banks, isn't it privacy violation? So I had a slide where it said that characteristics of blockchain is that it is transparent. So here it answers your question that everything is transparent. So if you're even concerned about the transparency so much, you will not use a blockchain technology. But even while being transparent, one of the most important features of blockchain technology is anonymity. You said that if you are able to view a transaction of a third person from 3-4 years back, you do not know who that third person was. Do you know who was the owner of this genetic kitty, and who was the other maybe potentially a funny guy on the other hand, who paid $117,000, $113,000. We just saw the corrected number on the public blockchain, who paid $113,000 for that digital kitty. You don't know who they are, right? You just know 2 public keys. Those are just cryptographic hashes. They are called public keys. They have separate private keys with them, with which those 2 people are logging into their wallets and seeing all their transactions and are transferring money and doing all that. It's just like you're logging into your Axis Bank app using your password and PIN. But because with your account number, Axis Bank account number, I also know whom that account belongs to. With this number, with this public key, I have no idea that Bharat Sharma paid 10 bitcoins to Abhishek Bhattacharya 2 days back. I just know a wallet address paid 10 bitcoins to another wallet address 2 days back. And after that, 30 different blocks have been covered. It is 30 blocks back. Hacking is it not possible. The transaction fee was maybe $2 in those 10 out of those in a transaction of $10. What the hash is, how much data it carried, what was the nonce, everything is available. So when you're building technical applications, Bharat, these all the concepts are very important, because when you're writing code, you are taking this data, what the transaction hash was, when was the transaction created, and that is what you display to the customer. You do not know who those 2 people were. It's public, it's anonymous. Not only public, it's anonymous. It's transparent, but it's anonymous. I think that answers the question. So it's not privacy violation. Privacy violation is when I know that Bharat Sharma transacted $10. Currently, I don't know that. I just know that $10 transaction happened. And not only I know that, maybe 21,000 different people in the Bitcoin network across the globe now know that, because they wrote it down in their own ledgers. Unlike in the case of Axis Bank, where only Axis Bank would have written it down in its own centralized ledger. I think that's it. Let's see if there is transaction cost, then centralized banks can be better. Yeah, ma'am, are you saying something? I have another question.
No. Then you can take another question.
Yeah. If there is transaction cost, Mr. Gupta, you have asked that if there is transaction cost, then centralized banks can be better. Then why blockchain is better? Ma'am, if you remember, then while I was telling you the difference between yesterday, if you were there, when I was telling you the difference between centralized systems and decentralized systems, and why the world, yesterday's half an hour was based on this only, that why the world was needing a technology that is decentralized. It's not about just the transaction fee. And believe me, you are paying quite a lot of transaction fee to your bank. If you are wanting to transact between, just let's say you're trying to send 3,000 euros to someone in Europe, you will be paying a hefty fee to that on that when you will be using the Swift payment channel, the Swift payment mechanism. So you are already paying a hefty fee to a centralized organization, where not only is the transaction fee is a demerit, but several other demerits are there, which we discussed yesterday. What happens if Axis Bank's records get deleted? What happens if Axis Bank faces a security breach? What happens to your transactions? You are gone, wiped off. Your database is wiped off completely of your balance and everything. In a blockchain, anything happens to a particular node, 10,000 different nodes, 100 different nodes are already having the same record. You must have seen in the video that I shared, 20 different people were writing that, okay, this guy has given a $25 or 25 franc fee for that particular doll that he was buying using cryptocurrency. Everyone wrote it down. The moment someone tampered with it and increased 100 to 1,000, that very moment, everyone else got to know that there is some problem because this guy's ledger does not match all of us. That is why whenever a majority of validators, a majority of nodes are on the same page regarding a particular transaction or a block, which is a set of transactions, the network considers it correct, because then everyone knows that whoever is not having that same ledger has done something in at their end. They are not decentralized anymore. They are maligned. This is the truth behind blockchain. So it's not just about transaction fee and everything. For everything you need a transaction fee, right? Because the miners are spending huge sums of money just to provide you that infrastructure set up across the world so that your transactions are mined in a decentralized way, not in a centralized manner, not by paying just your server costs. So he has to get something in return, because the core concept, which we could not cover today, consensus mechanisms, POW, POS, all these consensus mechanisms, why do they work? How do they work? And what do the miners get in between? Because they are doing a big community service by giving all those resources. They have to get something in return. So that is why the transaction fee. Who will pay the transaction fee, Ms. Matilda? You will be paying the transaction fee if you're the transaction owner. If you're initiating the transaction, you will have to pay the transaction fee, not the person receiving it, not the network. As the size of ledger increases, search time increases? No, because I'll tell you a concept. See, when Etherscan is searching, Etherscan is a decentralized app. It is a front end that is talking to the blockchain, that is talking to the backend, which is a blockchain network. So as a front end, it could be an Angular front end, right? It could be a React front end, built on React, built on Angular. What you will do is you will be do indexing on the fly, so that you make sure that you don't search in a manner which will make it slow. So searching on an Ethereum Explorer or a Bitcoin Explorer will not be very slow, because today's networks are very fast, pretty fast. But what happens when the size of ledger? Very good question. A very good concept comes out of this, which we would have discussed tomorrow. Let's discuss it in a minute. When the ledger size increases, what happens is running the network becomes more and more difficult. Why? The same network copy, as I have said, in a decentralized network, the same network copy which you must have seen in the video, BBC video as well, the same ledger, copy of the same ledger has to be kept with every node which is mining, right? Not mining, they are not even miners. Every node who is a part of the blockchain network, you'll have to have the entire blockchain's copy. On the dashboard, you'll find a link where you can download the Bitcoin Core application. What happens when you download the Bitcoin Core application? The first thing it does is it downloads the entire blockchain, Bitcoin blockchain, into your local computer. Currently, last I checked 1 month back, I was working on something. I have not checked the recent size. 1 month, 1.5 months back, Bitcoin blockchain had become 200 GBs big. So all that 200 GBs will first get downloaded into your system. If it's a laptop, I don't think, if it's a Mac, you won't have that kind of space, right? So that is why people have started using specialized systems to make them nodes. You don't make your laptops nodes anymore. And but that's what happens. So as the size increases, more and more nodes it becomes difficult for more and more nodes to keep a copy of that entire blockchain. A lot of technologies are being observed, especially in generation 3 blockchains, that they are trying a lot with sharding and sidechain and a lot of those stuff, where transactions can be made faster, the storage can be less, important information can only be shared on the network. These are all very futuristic concepts. We are not in a position to discuss them, but that is what happens when size increases. Pushpa, how many questions can we take right now? How many more? One more maybe?
You can take one more.
Let's take one more. 4:38. We'll close by 4:40. Then I'll try. Keep my explanation short. I'm trying to find out of all these attendance messages. Entrepreneurship guidelines are possible for any new startups. Where to start? Which direction to follow? How to deal with industry? Like you mentioned, food.
Hello.
Yeah. Hello.
Hello.
Yes, ma'am.
Actually, I have also selected one question from the chat box.
Please, ma'am. Yes.
Hello. I think this question is from Dr. Shilpi Sharma. She was asking ki 51% attack proofs blockchain is unhackable. Is it true?
Very much. Yesterday, ma'am, Thank you, Shilpi Sharma, ma'am. It's good to have you here again. Ma'am, you asked that 51%, the concept of 51% is makes it unhackable. It's absolutely true, because unhackable is always to an extent. Yesterday, I said a very important concept. The more the nodes, the merrier. Please make it a thumb rule whenever you're working in a blockchain system. The more the nodes, the merrier. Any blockchain that has the more number of nodes, it becomes stronger. Why? Because obviously 51% of 51% of two nodes, 51% of the network, when there are only two nodes, is one, right? Is anything above one, right? And when we are talking about maybe 10,000 nodes in a system, in a blockchain network, maybe a public blockchain network like Bitcoin, for achieving 51%, you have to go to 5100 nodes, talk to them, collude with them. So that is why, and to be honest, entire blockchain concept is based on the fact that more than 51% of the people of the nodes will be good. They will have benign intentions. They will be good. They will be honest, right? This is an underlying theory. This is an underlying hypothesis that even Satoshi Nakamoto has put it, I think, in his white paper as well, Bitcoin white paper as well, that this is the concept on which the blockchain technology is based on. So it might sound a bit different, but when it's a distributed network, there's very less chance that you'll be able to easily collude, right? In the case of banks, two people colluding will be physically present there, so they usually are able to collude, right? And they have a centralized ledger which they can move around. In the case of blockchains, making more than 51% nodes to turn to bad people, bad agents with malign intentions, it's one of the most difficult tasks, I believe, you can fairly imagine. So this is how it makes it so strong, because once 51% and more nodes say that yes, this is what the truth is, source of truth is, the finality, the entire blockchain usually carries that out, because that's the best way to understand and know that we are on the right path. The blockchain network is on the right path. So that is why that is why there is a theoretical concept, beautiful concept. I mentioned it in my book as well. 51% attack is very theoretical, because big blockchains like Bitcoin and Ethereum, they will never face attacks like 51% attack, because no one in the world will have that kind of resource to attack the blockchain network and roll back the blockchain network to a position by giving more resources than went into making those blocks. And once you do that, as I told you, and I'll also answer someone who asked about forking, once you do that, people will know that you have changed something in the blockchain. How will they know? Merkle trees, Merkle hashes, the tree will change, the Merkle hash will change, the hash of the root will change immediately. That will be reflected in everyone's ledger. This is how every node will get to know that some malign node has come into picture, and now the blockchain is not safe and secure and protected anymore. Let's fork it. Let's create a new blockchain. Go ahead with it. What are you left with? You spent humongous resources and money and electricity and all to break that blockchain, to roll back for nothing. You don't have the blockchain that you wanted to have. You may have changed a transaction of 10 Bitcoins, but you lost 20, 30, 50, 100 Bitcoins in return, because you spent that money. So yeah, I think that's an explanation to you, to your question, ma'am. I hope it answered.
Yes, definitely. Thank you, sir. One more question from audience side. I'm taking the question. This question is from Mr. Deepak Sharma.
Yeah.
Is there a concept of full node and partial node? He's asking, is there a concept of full node or partial node?
After that, Mr. Deepak Sharma has also said that what are full nodes and partial nodes, and then in that case, partial nodes. So you have answered, actually, Deepak, Mr. Deepak, you have already answered that. In that case, partial nodes do not need to keep copy of complete ledger. You are right, because that is what partial nodes are all about. So even in Bitcoin Explorer, if you're a partial node, you don't have to keep a copy of the entire node. That's a concept I was saying, that people have tried out some concepts. This is one of them. So when you're having a partial node, you don't have to keep the entire blockchain at your locally. But again, then you are limited in those transactions that are in that part of the blockchain that you are hosting. So what happens is that if you have work with if you have to tally any other transaction that is outside of your repository, you will have to contact the main blockchain. So that is how people are trying to make partial nodes, more and more partial nodes a part of the system, so that the blockchain network can be divided and still run. Because there's a lack of full nodes. Not a lot of people are now gradually able to provide those resources to have all that data in a single node. So yeah, so that's why partial and full nodes are used. Out of the scope of this course, but it's covered in my book if you get a chance to get a hands on that. So I think that answers your question. Yes, because lesser number of nodes is mean that the blockchain will be less secure, as I've been telling since yesterday. The more the merrier, the more number of nodes, the merrier, because obviously 51% calculation comes down to a lot more number of nodes. You have total nodes are more. Simple math. Yes, ma'am.
Okay, from my side done.
Yeah, ma'am, once someone asked that entrepreneurship guidelines, if possible, for any new startups, where to start, which direction to follow to link with industry, like you mentioned, food. So I wanted to cover good use cases. Even I wanted to cover my own startup use case, because we are using blockchain very in a very deep manner. And but we don't have time for that, so we'll definitely discuss. Else I'll put it on the dashboard. One concept, please remember, yesterday I shared it as a myth of blockchain. Do not apply blockchain to any business you run. That will only make it pricey and unaffordable for you. If your business model cannot utilize the core concepts of blockchain, why I'm putting so much stress on this? Because a lot of entrepreneurs, after the blockchain hype, a lot of entrepreneurs just wanted to try out blockchain, and whatever they are doing. With that, they created a lot of havoc. They failed miserably because they wanted to apply blockchain technology to just anything they were doing. I had a poll where I had asked that, would you want to, if you're building a service like Netflix, would you want to do it on blockchain or not? The clear answer to that poll, which I was not able to run, is that no. What will you do by putting video resources on blockchain? First of all, you can't do that. That's not what blockchain is for. You cannot do that. That's not technically possible. Also, why will you do that? Who is releasing? Why will Netflix anyways be releasing false content? They will not, right? They will be only releasing licensed content. So why do you need a network that is transparent, secure, and public and anonymous? You don't need that. You'll be only miserably failing if you're doing so. So that is something you should keep in mind. We'll discuss very good use cases. Amazon's implementation of a supply chain network tomorrow, if we get time. My own startup's implementation, which is being run in Maharashtra government. And we were the first network, we were the first implementation on the Maharashtra blockchain sandbox, Maharashtra government blockchain sandbox. And the government sandbox is the first in the country itself as well. So we are the first implementation, world is the first implementation on the blockchain sandbox in the country. Yeah, so that's where it is. Any other question, please put it on the dashboard or anywhere else, just on the WhatsApp group, anywhere else you find. If you failed to fill yesterday's attendance form, please log in via this name every day you're joining. If you're joining tomorrow, use your own name. We'll take the information for the better. That's it, ma'am. I think Pushpa ma'am, I'm done.
Okay. So thank you, Abhishek, for providing us valuable information about public and private blockchain, Genesis block, Merkle tree, hash function, and explanation of the public, in fact, practical explanation of public Ethereum block. So really, I have joined this session, day 2 session very much. And thank you all for attending the day 2 FDP session on blockchain. I hope you also find day 2 session more informative and more interactive. And once again, thank you all. Please stay connected on Sunday also, same time for day 3 session. Okay, Abhishek?
Please fill the feedback form I posted on the chat, and also the dashboard is there. These are the resources to help you. Feedback is of course to help me. If you post any feedback today, again, I'll try to reflect that tomorrow itself and any time in the future. Thank you very much. Thanks a lot. And I hope I was able to cover some practical aspect to keep you going today. Yeah, thank you, ma'am.